Question and answers on average and root mean square values.
Okay, so welcome to this episode. And within this episode, we'll be talking about examples on the average and the root mean square value. So we'll be solving some examples on the average and the root mean square value. So this is the first question, for example, we like to solve. Okay. So now with this question, for instance, we are asked to calculate the average and the effective value of the voltage below. So this is a waveform of a voltage, of a certain voltage, and we are asked to calculate the average voltage, the average value of the voltage, and the effective value of the voltage. And we also know that the effective value is the same as the root mean square value. So now I want to solve this question simultaneously so that you understand how to find the average value and the root mean square value. So what I want to do here is that I want to be solving the average value or the average value of the voltage on this side, and I'll be doing the root mean square doing the RMS value on this side. Okay, so now let's look at it. So this is the question. First of all, what do we need? We need the period and we need the cycle. So let's write it here. So the cycle span for this particular question, we want to know the repeating. So the cycle, we have the sinusoidal wave and have a triangular wave, and it continues like that. So the cycle span is simple from 0 to 2 pi. So this is one cycle, and the cycle repeats itself again. So that is the cycle span. So to get the cycle span, then our period, which is the t, obviously, is 2 pi. Our period is 2 pi. So now the average value, we have to calculate the average value and the voltage value. But to find the average value, we need the area and the period. So we need the area under the function divided by the t to find the average value. The same way, we need the area, the square root of the area of the function square divided by t to find our root mean square value. So these are basically some things that we need to find it. Okay, so since we understand these things, then let's go here. So when you come to the average value here, our t, which is our period, is 2 pi. The same as the root mean square value, our period is 2 pi. I'm solving simultaneously because I want you to know how the things go. You could have finished one and go by the other. No, but I want us to know how it goes. That's why I'm doing simultaneously. Okay, so now, because there is two different wave diagrams here, you have to find the area of the two different wave diagrams and you find the total area. So now, if AS is equal to the sinusoidal area, so the sinusoidal area, and let's say AT is equal to the triangular area, then our total area would therefore be equal to the AS plus the AT. Okay, so if you understand this, then, okay, so let me clean this one for the meantime because I'll come and continue from this side. Okay, so if you understand this, then we can go ahead and find the AS, which is the sinusoidal area, under the average value. So now, to find this, because this is a sinusoidal quantity, the sinusoidal area, simple, is the integral of 0 from 0 to pi. So the integral of 0 to pi, the peak value. So the peak value here is what? Is Vm. So that is the peak value. So it's Vm sine of omega t. So the omega t is this quantity, that is the theta, sine theta the theta. Okay, so now how do you find the AX? So the AX simple becomes to this. Now we change this to cos, which will give you minus Vm cos of theta to the theta. And we can bring the Vm out, so it becomes minus Vm, the integral of this to pi cos theta the theta. Okay, so now okay, so this is when we've integrated the function. So now what happens here is that when you integrate, anytime you integrate sign, you get minus. That is why the minus came in. So we can change this straightforward too. So you are still finding the average value on this side. So you can change this straightforward to minus Vm, which is the cos theta, and you put in the limit 0 to theta. So now when we integrate sine theta, you get a negative cos theta. That is why I have the minus cos theta over here. So we integrated the sine theta. This one is a fixed quantity. Okay, so minus Vm. So now here we still get our AX to be equal to minus Vm into bracket cos of the cos of pi minus cos 0. So now what is cos of pi? Cos of pi is minus 1 and cos 0 is also 1. So therefore A of x becomes minus Vm, which is equal to minus Vm into bracket minus 1 minus 1. So minus cos pi is minus 1 and cos theta is minus 1. So therefore A of x simply becomes 2 Vm. So now this is value for our A of x. In the same way, we have to find the A of t, that is the triangular side. We are still finding the average value. So the triangular side is simple. It's half times the base times the height. And what is the base? The base is what? It's pi, and the height is the Vm. Between here and here is pi. 2 pi minus pi is pi. So now it's half times pi times the height, which is Vm. So therefore now it's equal to Vm on 2 pi. So when you have this, then the total area is simply the total area for this simply becomes 2 Vm plus Vm on 2 pi. So this is the value for the total area. Okay, now let's come to find the total area for the RMS value 2. The area for RMS value 2. Now the V naught here, for RMS value, we say we have to square it. We have to square the cycle. So we square the V naught here, and that will become Vm squared. So now, when you square the cycle, the same way we have to find the sinusoidal area and the triangular area, and after we find the total area. So now, finding the sinusoidal area for the Vm squared here, that becomes 0 to theta Vm squared sine squared theta d theta. So because this is squared, it is affecting the whole sinusoidal quantity. So therefore, the area of the sinusoidal curve simply becomes theta, that is Vm squared, and this parameter here can simply become 1 minus cos 2 theta all on 2 the theta. Okay, so now the AS can simply be, if you solve for this, or if you simplify this, this is frequency, you can bring it outside, theta 1 minus cos 2 theta all on 2 the theta. So now when you integrate this function, when you integrate this particular function, in short, okay, let me write it here. When you integrate this particular function, in short, you get Vms squared over 2 pi. So when you integrate this function and you put in your values for the the limit, you will get VMS square over 2 pi. And now how do you find this? 80. So yes, this side we are finding the RMS value. It's also this side. So now how do you find the 80? That's the area of the triangular side. So now realize that anytime you want to find, because the VMS square, the VM or the peak value is squared, we always say the area under a squared right angled triangle is BH squared on 3. We've established this fact already. So now if the area is that, then the base here is still what? It's still pi. So the base is still pi times the height, which is what? Vm squared, all divided by what? 3. So therefore, the area under it is Vm squared pi on 3. So the total area of the root mean square, the total area becomes the AX plus the 80. And the AX here is the Vm squared on 2 pi plus Vm squared pi on 3. And when you do this, you will get, I think, 5 on 6, 5 on 6 Vm squared pi. And this becomes the total area. So now the total area under the average value was 2 Vm plus Vm pi on 2. And this is the total area under the root mean square value. Okay, so now what do you do again? Since you have the total area and the total area here, we come back to the average value. The average value is that to find the mean average, it's simply the area of the function. The area under the function, this is the area divided by 2. And I have t as 2 pi. Our t here is 2 pi. So therefore the area is simple. You put this 2 Vm plus Vm pi on 2, all divided by 2 pi. When you do this, our final average simple becomes, okay, so when you substitute this, the whole of this, you are getting Vm into bracket pi plus 4, all divided by 4 pi. And this is the value. So this whole is what? Volt is the value for what? The average value of what? The voltage V. Okay. Now when we come to the root mean square value, how do you go about that one too? You have the total area here, so you have to find the mean. The mean. So now the mean here is simply the area of the. So the mean here is simply the area of the squared function, the area under the squared function divided by t. And this is the area, so therefore it becomes 5 on 6 Vm squared pi, all divided by 2 pi. And when you do this, you get 5 on 12 Vm squared, because pi will take pi away, and these two multiply the 6. So now when you have this, it doesn't get, it's not ended there. So now it is what? The VRMS, that's the effective value of the voltage, simply becomes the square root of the mean, which is 5 on 12 Vm squared. So the square root of the mean simply becomes Vm root of 5 on 12 volts. And this is the effective value of the voltage, and this is the average value of the voltage. So this is the first question under the root mean square value, and we would like to also solve a second question. Okay, so this is the second question we'll be solving for the day. And the question reads, a 200 watt laptop is connected to a 240 AC line, a 240 volts, that's AC line. That is simple to say, that is the VRMS, so the root mean square value of the voltage, that is the AC line. And it says calculate the RMS current flowing through the outlet. That is the first question. The second says to determine the peak current. The third, determine the peak voltage. And the last, you calculate the maximum power that is delivered from the AC line. Now, to solve this question very well, you have to understand one or two things. That anytime you want to find a peak voltage, it is root of 2 multiplying the V RMS. The same way, if you want to find a peak current, it is root of 2 multiplying the R RMS. Average average power. If you want to find the average power, it's always the V RMS multiplying the I RMS, because you understand that in R is equal to V and power is equal to V on R. Sorry, V square on R. So you can say power is also equal to V times I. Power is equal to IV. So from this relation, that is when you are getting this. Okay. So now, maximum power is also equal to I naught times V naught. So the average power is equal to the average, the root mean square value in the root mean square current. And this one is equal to the peak current and the peak voltage. So have these formulas in your head, and I think that will help you solve this particular question. Okay, so when you come to this question, to solve this question, the solution to this question, it says you have a 200 watt. So this 200 watt is connected to this particular voltage line. So this 200 watt is simple, the average power. So this is the average power, which is 200 watt. And this average power is connected to the root mean square voltage value, which is 240 volts. Okay. Now the question says you should calculate the root mean square current. So that means the RMS current. How do you calculate for the RMS current? So take note that we said the average power is equal to VRMS dot IRMS. So therefore, the average power divided by VRMS will give you the IRMS. Okay, so if you get this, then it becomes very simple. The IRMS is equal to, which is 200 on 240, which is 0.833 ampere. So this is the answer to the first question, the IRMS. Okay, so getting the IRMS, the B part, it says we should calculate the peak current. So the peak current is what? The I naught, and which is equal to root 2 times IRMS. So that is root 2 times the RMS we found here, which is 0.8333 ampere. And when you do this, you are getting 1.1785 ampere. This becomes your value for the peak current. So the C part is peak voltage, which is V naught. And V naught is simple root of 2 VRMS. And what is the VRMS? That is 240 volts. So now V naught is equal to root of 2 times 240. And when you do this, V naught will give you 339.4 volts. Okay, now the last question, which is the D aspect, says you should calculate the maximum power. Take note, maximum power delivered from the AC. And this is the maximum power. As the formula goes here, I naught times V naught. And I naught was what? 1.1785 multiplying 339.4 volts. So when you do this, you'll be getting 400 watts. And that becomes the maximum power. So this brings us to the end of the examples of the average and the root mean square values. I'd like you to go and get more questions to solve with respect to root mean square and other stuff. And we'll meet for the next, that is the soda quantities. Thank you very much.